This lesson is from our textbook, section 8.5. It's on solving rational equations and inequalities. We'll be focusing on equations today. A rational equation is an equation that contains one or more rational expression. The time t in hours that it takes to travel d miles can be determined by using the equation t equals d over r. So again, that's time equals distance over rate. R is the average rate of speed. The equation is a rational equation. So we've been working with rational expressions, which is just a fraction. Two polynomials being divided is what we are working with, adding, subtracting, multiplying, dividing. And so we just had expressions. Now we're introducing it with an equal sign. So it is a rational equation. To solve a rational equation, you're going to start by multiplying each term of the equation by the least common denominator of all the expressions in the equation. So this is a nice shortcut. We are not going to start with that shortcut, but we will introduce it and solve two different ways. So when we look at this, that is a nice shortcut, is multiply everything by the least common denominator, the entire expression on both sides. This step eliminates denominators of the rational expressions, and it results in an equation you can solve by using algebra. So you really do need to understand your rules for fractions, okay? So there's two ways I'm going to show you how to do this first problem. And the first way is, if you're really unsure of that shortcut and canceling out, this is the way I would do it. And so again, if you're working with some fractions, you want to make everything a fraction. So I'm going to put this over 1. And if I'm looking at this, there's a couple ways I could do this. In order to do anything, I need to build a common denominator. I need to get this to be a fraction. So I'm going to multiply the bottom and the top by x. So on the left-hand side, I have x squared plus 8 all over x, and that equals 6. So the first thing I did, and again, I'm not using this rule right now. I'm just using my old skills of adding fractions by building a common denominator. And then the idea here, if you really wanted to, is you could put this over 1, and then you could cross multiply. Now, for this problem, that works. But if I have more than a 6 over here, if I have an x minus something, or I have a quadratic, that's going to make a huge mess. So it'd actually be better not to cross multiply. In a simple problem, I can, but once they get more on the right-hand side, we're not going to want to do that. So one way of doing this, it's a variation of the shortcut, is to build a common denominator across the entire problem. So if this is built with an x, I'm going to build this with an x under it and put an x on here. So I basically built a common denominator for each piece of my rational equation. And so now I have that x squared plus 8 would equal 6x. So how did I do that? How did I get rid of that denominator? The way I got rid of the denominator is by looking at it. If you think about having a over b equals c over b, if my denominators are equal, don't my numerators have to be equal? If a over b equals c over b, then a has to equal c. Okay. The other way, if I would have cross multiplied with this, no cross canceling, only with multiplication. If I would have cross multiplied with this denominator, I would have multiplied this side by x, I would have multiplied this side by x, and then the x's would cancel out. So by building a common denominator across an equal sign, I can get rid of my denominator. That only works with an equal sign. So the way I solved this was I built a common denominator on entire problem. And then I need to remind you that there must be an equal sign. So I cannot get rid of a denominator when I'm adding or subtracting or multiplying, dividing. I can only clear a denominator if I have a fraction equal to fraction, because if my denominators are equal, then my numerators are equal. So this is a nice shortcut, but not as confusing as this one can be. So I built a common denominator so I can keep that idea. I adjusted the top, and now I can set the top equal. Now this takes us back to some previous knowledge. Once I've cleared my fractions denominator, I am right here, and I have a quadratic. So I'm going to use my skills of setting my quadratic equal to 0. Again, these are prior knowledge skills. Subtract the 6x, I have it in standard form, and if I can, I'm going to go ahead and factor and solve. So I am using zero product property to solve this problem. We've been using zero product property to help us with domain restrictions. So when I go to factor, I'm going to go with x minus 4 and x minus 2, and then my final answers are x equals 2 and x equals 4. I get my 4 from there and my 2 from there. Before I say I'm done, we've been talking a lot about domain restrictions. I need to check my domain restriction. Notice in the directions it does not say anything about domain restriction. Just solve the equation. I need the domain restriction because it might falsify one of my answers. So go back up to the original. My common denominator was x. That was the only thing I had. So x cannot be 0. So my domain restriction does not interfere with my answers. Okay, in order to check this, we want to see if I go back to the very original and I put the answer 2 in, does it work? So that'd be 2 plus 8 over 2. Does that equal 6? Well, that's 2 plus 4. Absolutely, 6 equals 6. I'm good. So x equals 2 works. Let's check and see if x equals 4. Again, we're plugging it back to the original. 4 plus 8 over 4 equals 6. That's 4 plus 2. Perfect. 6 equals 6. I've got it. Okay. Sorry, a little bit off the paper there. So the way I would recommend solving these, if you're sort of on the edge and not as comfortable with this, is I would build a common denominator for all of the pieces. And as long as you have an equal sign, once you build that common denominator and you adjust the numerators by top and bottom, then you can cancel out that common denominator. Okay? Only because you have equal sign, only because it's truly going to say these are equal to each other, the numerators are equal. Or it would cancel itself out when you cross multiply. Now, the other theory of doing this, so this is like method 1. So this is fine, you can stick with this. The other method you're going to see out there is definitely a shortcut, and it's great if you can do it. So I'm going to go back to that original problem of x plus 8 over x equals 6. And so what I want to do is I want to look and say, what would be my common denominator? If I put everything over here, my common denominator would be x. So what I do is I multiply everything in the problem by x. And so what happens when I do this is I distribute and I get x squared. But when I take x times 8 over x, this x cancels and it leaves me just the 8. And then equals 6x. So it is a great shortcut. It doesn't shortcut it that much. I still have to build the top. I'm just not showing the denominator. And so you can see that I get the same thing and I would solve it the same way. So the shortcut method 2 is when you multiply everything, and that's important, multiply everything on both sides by your common denominator. So one of the reasons I'm going to lean towards not using this method is because of the errors I see. I see a lot of people only cancel things, they don't multiply everything by it. So if you're comfortable with this method, I think that's great, use it. I'm going to show this method because it's a little more tangible for people. Alright, so here we go. I know that was a little bit long, but I wanted to really detail those first couple examples. So now we have some problems to try, and so this is where you're welcome to pause the video and give it a try yourself. So I am looking at this and I see that I have a 3, I have an x, and a 1. So whether I'm going to do method 1 or method 2, I want to build a common denominator across the entire problem. Okay? Again, I could come in and build a common denominator here and then cross multiply. I'm trying to avoid that because when the problems get bigger, I don't want to cross multiply. So I'm going to go ahead and look and say for everything to have a common denominator, I would need a 3x. So this needs an x, and this needs a 3, and this needs a 3x. So what do I have? On the left, I have 10x over 3x equals, and on the right, I have 12 plus 6x all over 3x. So here I go, 10x over 3x. I've got the 12 plus 6x, and my common denominator is 3x. So here's, if I wanted to, I could cross multiply, but that ends up making a mess. I don't want extra x squareds. So what I'm going to do is look at this. I have the same denominator. That means if my denominators are equal, then my numerators are equal. So I can simply write that 10x equals 12 plus 6x. All right? Some of you will catch this, that, okay, once I build that common denominator, if I change the bottom, I change the top, I don't even have to write the denominator again. I've set my denominators equal, so that means my numerators are equal. This one is just linear because there's no degree of 2 here, so I can just solve by moving, and I get 4x equals 12. Divide both sides by 4, and I've got x equals 3. I need to come back and do my domain restriction. What can't x equal? Go back to the original. 3 will always be 3. X can't be 0. No domain restriction here. So that is my final answer. All right. Another one very similar. One of the things I want to be really careful with is negative sign, so I'm going to put it up here. That way I don't lose it. You don't have to do that, but that might help. We've talked before about distributing negative signs to everything in the numerator. Okay, so I need a common denominator. I want to get it across the board here. If I get just the common denominator over here, I still have to do extra work. So if I just do it all, a little extra early work now, that's going to help. So I'm going to multiply here everything by 4, multiply everything here by x, and again here by x. So what I have going on, I have a 24 plus 5x on the top, and I have a common denominator of 4x, and that equals negative 7x over 4x. So I think it's good just to double check. I made a common denominator. If I wrote it on the bottom, I wrote it on the top, and here's where I have it. So see, my denominators are equal, then my numerators must be equal. And notice I didn't lose my negative sign. Okay, again, I just have a linear equation, so I'm going to go ahead and solve it by just doing my order of operations. And I've got 24 equals negative 12x, divide both sides by negative 12, and I get x equals negative 2. Watch your negative signs. And let's go back up for our domain restriction. I only have a denominator with x over here, so x can't be 0. And that's it. All right, we have one more here. Common mistakes are we forget about that -1. If you can't beat them, join them. That's what we say in the fraction world. Okay? So if I have a fraction, make everything else a fraction. And what would my common denominator be? Well, I just need an x. So this needs an x and an extra one there, and that needs an x and an extra one there. So at this point, I would be comfortable to say, hey, listen, I've got x squared equals 6 minus x. I'm ready to go. But if you're uncomfortable with that, let's take a second and rewrite it. I have x squared over x. All right, over here I had a common denominator of x, and I had 6 minus x. So here we see we have the same denominator, so let's set our numerators equal to each other. And you can see I do have a quadratic. I'm choosing to leave the x squared positive, so I'm going to add the x over. I'm going to subtract the 6, and again set it equal to 0. All right, so looking at this, I'm going to factor it, and it should be an x. I got a little overzealous there. So I'm going to have x, maybe. That's not looking so good. Okay, so I'm going to have x plus 3, x minus 2. Again, always double checking our signs that they multiply right to -6 and they add up to 1. And then with that, x equals -3 or +2. So we are using our zero product property in solving quadratics. And my domain restriction is, again, x cannot be 0. And the reason we keep getting that x cannot be 0 is because our denominator is simply an x. Okay, so those were a little bit of easier examples to get us going. We didn't have any major pieces to deal with, and so we're going to keep moving on here and practicing more. All right, so you can see there's a little bit more to these problems, but we're also going to talk about extraneous solutions, or you might see the word erroneous solutions or false solutions. All right, so extraneous solutions is a solution of an equation derived from the original equation that is not a solution of the original equation. Basically, in short, you get these extraneous solutions because they interfere with a domain restriction. Something that we have canceled out and not worried about hasn't affected our answer will affect us if we go back to the beginning. So when you solve a rational equation, it's possible to get these extraneous solutions. These values should be eliminated from the solution set. Always check your solutions by substituting into the original equation. I also say consider your domain restrictions. So yes, you should, and I have not been good about it, we should have been checking all of our answers by plugging them back in, but the domain restriction is also a good way of throwing out any extraneous solutions. Plugging your answers back in also tells you, did you make an error? So the first thing I see here is I have a fraction equal to fraction. If I wanted to cross multiply, I could, but I'm making a mess. If I cross multiplied, and remember, I cannot cross cancel unless it's multiplication. But when I cross multiply, that rule is that I take a over b equals c over d. I can only cross multiply when I have an equal sign, and I take a times d, and I set that equal to b times c. And that's exactly what I could do. I could take this times this, and this times this. Now if I do that, I'm going to get quadratics, I'm going to have to FOIL, and I have a big mess. So what's the shortcut? I have a common denominator. I have a common denominator over an equal sign. So if my denominators are equal, then my numerators are equal. So it's not that I'm canceling out or throwing out my denominator. I'm not canceling like I do with multiplication, because that's not top to bottom. But if I have a common denominator, then my numerators should be equal to each other. So 3x equals 2x plus 3. I have a simple linear equation. So when I go to solve that, I subtract the 2x, and I get x equals 3. Now the issue is if I leave that answer and I walk away, I just got it wrong. Because if I would consider the domain restriction from the original denominators, the denominator cannot be 0, so x cannot be 3. Unfortunately, that is my answer. So I have to throw out my answer, and to receive full credit, you would say there are no solutions for this. You could write no solutions, or you could write the null set, N-U-L-L, the null set. Okay? So the idea is knowing my domain restriction, accounting for that denominator not being able to be 0, throws out my answer. Because when I solved it, I was not focusing on the denominator. All right, how do I check it? To check it, substitute x equals 3 into the original equation. And let's watch what happens here. I substitute in 3 times 3 in the top is fine. That's the issue. 2 times 3 plus 3 over 3 minus 3. So you can look in the top, I have 9 over 0 equals, that'd be 6 plus 3, 9 over 0. Okay, well I can't divide by 0, that is undefined. So that's why 3 cannot work. Really sorry about that. So if I plug these in, I do get an equivalent statement, but I can't have something divided by 0. It's undefined. So that domain restriction let us know that we had an extraneous solution. Okay, this one's not so easy. All right, I have a common denominator on the x minus 7s, but then I have that 2. So we have to go back to use our skills of building common denominators and get that base so we can cancel it out and use it. Now, here's what I want to remind you. My common denominator is 2x minus 7. So if I wanted to really shortcut this, I'd multiply everything over here by 2x minus 7 and everything over here by 2 times the quantity x minus 7. But I do have to be careful with that and what's left over. So again, it is wonderful if you can do that, but I'm going to go ahead and just build that common denominator because I find it helps more students and I find it causes less errors. But if you're advanced with this, I think that's great. Use that shortcut. So multiply the top and bottom by 2. I need to multiply this by x minus 7. Multiply this by x minus 7. And remember, I need it, the whole thing. And then this needs a 2. So I am truly doing the same thing as the shortcut. I'm just showing it. Okay? I now have a common denominator, guys. I now have 2 times x minus 7. And I have on the other side 2 times x minus 7. So at this point in the game, I'd stop writing it. I know I built a common denominator. I'm going to focus on the top. Now, I have on the right-hand side just a 10. But on the left, I have 4x minus 18 plus, and then I have x squared minus 7x. All right, I ran out of room there. So, do I have a common denominator? Absolutely. Then my numerators are equal to each other. So on the left, I have x squared minus 3x minus 18 equals 10. So again, I took the time to distribute, and then I added like terms on the left-hand side. I have it set equal to 10. And I think I have a slight error here. Let me double check. Nope, I think I'm good. Okay, next thing I'm going to do is I'm going to set it equal to 0 because I have a quadratic. So I'm using those old skills, and I have x squared minus 3x minus 28 is equal to 0. And again, there are several ways to solve a quadratic. These problems are made to solve by factoring, but if it didn't factor, I could use the quadratic formula. I could graph to find the zeros, the x-intercepts. I could use completing the square, or if possible, square roots, which is not possible in this one. I would like to factor and use my zero product property. So I'm going to go with x minus 7 and x plus 4. Again, double check your signs. And now that I know that this works, my answers are x equals 7 or negative 4. Again, if I just walk away, I might have a wrong answer. So I need to do two things. I need to talk about my domain restriction. What can't x be? Go back to the original. X can't be 7. 2 will always be 2, and x can't be 7. So my denominator cannot be a 0. So since x can't be 7, I'm going to throw out that answer, and my final answer is just x is negative 4. So if I only have one answer, and that answer gets thrown out by my domain restriction, I have no solutions. If I have two answers and one gets thrown out, they could both get thrown out, but if only one gets thrown out, I still have one answer. So how do I check this? Again, I'm going to take my x equals negative 4, I'm going to plug it in. So 2 times negative 4 minus 9 over negative 4 minus 7 plus negative 4 over 2 should equal 5 over negative 4 minus 7. Okay, so now that I have my original problem written, I'm going to go ahead and clean this up. I have negative 8 minus 9 over negative 11. And I guess I will leave this as negative 4 over 2, and that equals 5 over negative 11. All right. So here we go. I have negative 17. I feel like I have an error. I'm going to pause here and double check. All right, I was doubting myself because these numbers aren't so pretty. I end up with negative 17 over negative 11, so those cancel. And then I have minus 2 equals 5 over negative 11. So at this point, we could do some math and get a common denominator, but I'm just going to throw it in the calculator. And when I take 17/11 minus 2, I end up with 0.45 repeating. And if I take 5 over negative 11, I get, a negative 0.45 repeating, and here I get a negative 0.45 repeating again. So I do have equal answers here. If I would try to take that 7 and plug that 7 in, it will work in just the top, but when I put the 7 in here, I will get a 0. Okay, So that's great. We have a couple more problems. So I have 2 more check it outs, and then down here we have some challenge problems, and I really think this is worth the time to get into these problems because they have a little bit of extra to them. All right, so again, here's a great place to pause this video and try these problems on your own. All right, so here's the deal with this one. I don't want to cross multiply if I don't have to, because it's just going to be a little bit messier. This problem would be okay to cross multiply, but I'm going to choose not to. So what I want to do is I want to go back to adding, subtracting, and think about the rules of adding, subtracting. I need a common denominator. There is no addition or subtraction here, but if I build a common denominator over an equal sign, then my denominators can cancel. And I want to clarify something. Alright, so I am looking at this, and I'm going to break it down to x minus 4 and x plus 4. And that is perfect. Because I'm thinking about building a common denominator. They both have the x minus 4. And so all I have to do is give this an x plus 4. Change the bottom, change the top. And then I'm going to stop right here. I'm going to look at this. Do I have a common denominator? Absolutely. Do I have an equal sign? Yepers. So if I have a common denominator with an equal sign, then my numerator must equal my numerator. So at this point, I can cancel out my denominator knowing that they would cross multiply and divide out, or know that my denominators are equal, so my numerators are equal. So I have 16 equals. I'm going to go ahead and distribute that. 2x plus 8. And it's a linear equation, so I can go ahead and solve by subtracting 8. And I have 8 equals 2x. Divide both sides by 2, and x equals 4. Now we want to double check those domain restrictions, and some of you are already ahead of me. My domain restriction goes back to the original before anything got canceled out, and I had x as negative 4 and x plus 4. So x cannot be 4 or x cannot be negative 4, and that indeed cancels out my answer. So my final answer is no solution or the null set. So make sure you're real clear that you throw out the answer or which answer doesn't work and restate your answer or restate as no solution. Okay, so here we go with another problem. I can see that these two have an x minus 1 and that doesn't. So even though it's added on and it just has a 6, I cannot do anything till I build it up. So this needs an x minus 1. And these need the 6. So I ask myself again, without rewriting all this, do I have a common denominator and do I have an equal sign? Common denominator over an equal sign means that my numerators are equal. So here's my 6x minus 1. This would go together as 6 and x minus 1 as a common denominator. So my numerators are equal. So I have 6 is equal to, here's 6x, distribute that, and that would be plus x squared minus x. All right, well now that I have that, I need to add like terms. So I have 6 equals, I'm going to move it around, x squared plus 5x. And I have a quadratic again, so I'm going to set it equal to 0. And I'm going to subtract the 6. And then here we go. Set it up, x times x, and then I would want I want this to be a plus 6 and a minus 1. I had to be careful there because a lot of times I want to do 2 and 3. 2 and 3 multiplies to 6, not negative 6. 2 and 3 multiplies to 6 and it adds up to 5. But if I make one of them a negative, it doesn't work. So this is the one that always gets people. But now that I have it, I have 0. Well, I don't need the 0. I have x equals. I have x equals a negative 6 or a positive 1. All right, if we go back to that domain restriction idea, x cannot equal. There's a 6 and there's an x minus 1. The 6 will always be 6, but x minus 1 could be 0 if x is 1. So that throws that out. My final answer is x equals negative 6. All right, so that really is the lesson. but I think it's important to talk about some extra problems here. So here is a great problem to start with. Again, this is where if you want to pause and try these problems yourself, I think that is a good thing to do. All right, so here we go. I do not have a common denominator, and I absolutely do not want to cross multiply. And the reason I don't want to cross multiply, I don't want x to the third. So I want to get rid of this. And so I need to find a common denominator. And these are not common denominators, and I certainly don't want to multiply them by each other. So let's go back to basics and break this down. How does this one factor? I'm going to go with x plus 3, x minus 2. And this factors as x minus 8, x plus 3. Okay, that's really good because what do you see? They both have x plus 3. Fabulous. All right, so here's the deal. I need to build this up. If this has an x minus 8, then this needs an x minus 8. And don't forget, I changed the bottom, I changed the top. Now I'm doing this in 2 different colors to really show the difference. Obviously, you can do it just all in pencil or pen, but if you have an extra color, for some people that helps because then they remember that they did change it, that they're looking back and they realize, oh, this was the original problem and that was not. So sometimes the extra color is worth it to sort of help if you have to look back at it. Okay, so I know my denominator is a mess. I have 3 things here and 3 things here. But because I have an equal sign, my numerator is equal to my numerator. That means, and I'm going to go ahead and distribute, I have a 4x squared minus 32x, and that is equal to, let's go ahead and distribute, 7x squared minus 14x. So you need to really think about this. Common denominator on both sides? Absolutely. Then this is what's left in top. Okay, so again, I just distributed, brought it down. I definitely have an x squared, and I have an x, so I do have a quadratic. So I'm going to go ahead and set it equal to 0. I'm going to move the 4x over. I'm going to subtract 4x squared, and at the same time, if it's okay for you, I'm going to add the 32x and add the 32x. So these cancel, and I have 0 equals 3x squared, and it's going to be plus 18x. All right, wanted to double check my math there. A lot of people get stuck on here, but this is easy factoring. It's not going to factor as a reverse FOIL. It's going to factor just a GCF of 3x out, and what's left is x plus 6. All right, so what does x equal? Well, 3 times 0, okay, so x could be 0 or x could be negative 6. Do I have any domain restrictions that interfere with my answer? Go back up to the original denominator. X cannot be negative 3. X cannot be 2. X cannot be 8. And again, we had that negative 3. So my domain restriction does not overlap with my answer. So I should not have any extraneous solutions. And what you could do is take the time, take your answers, plug it in, and make sure they work. Okay, so we have another example here. I don't really think this is as much of a challenge. I think we've already done some like this. But what I want to remind you of, seeing that x plus 3, I don't want you to make the mistake and put a plus 3 here. If this has an x plus 3, then this needs a whole piece x plus 3, top and bottom. And if that has an x plus 3, then this needs it. And this needs an x and an x. So here I go again. Even though I have 2 pieces over here, this would funnel down to be a common denominator of x and x plus 3, and we have the same denominator over here. So I have my numerator, x plus 3 plus 3x is equal to, and let's go ahead and distribute that, 6x plus 18. Okay, so I'm looking at this and cleaning it up. I have 4x plus 3 equals 6x plus 18. I'm going to move some things around. I'm going to subtract the 4x. And at the same time, I'm going to subtract 18, and I get negative 15 is equal to 2x. And then I'm going to divide both sides by 2. So I end up with negative 15 halves. Maybe you would write it as negative 7.5 or negative 7.5. Either way, it's equivalent. And let's talk about those domain restrictions. What can't x equal? And I want to be real clear. Make sure you have your x equals, and make sure you're stating that x cannot equal for domain restriction. So go back to your denominator. X cannot be 0 or negative 3. And that does not interfere with my answer of negative 7.5, so I'm set. Okay, I think the only thing that makes this a challenge problem is that negative sign. And that shouldn't be a challenge because we've talked about it and focused on it. So let me show you a couple things. The first thing I would do is change that sign and put it there. And I already talked about that in this lesson. It will affect us here. And the reason it's going to affect us is when I go to build that common denominator, this needs a 5, this needs an x minus 3, and that's where the problem is. When I go to distribute this x, I should be distributing a negative x. So that's what I want to remember, because if I don't change that now, I'm probably going to get the wrong sign. I'm probably going to forget to change that. And this needs a 5. Okay, and even though the numerator had a 5 in it, I have to put 1 there. So I have these two questions for you. Do I have a common denominator for each piece? And do I have an equal sign? If so, if my denominators are equal, then my numerators are equal. So you could rewrite this numerator, but I'm going to go ahead and distribute it. So it's 5x plus 10 minus x squared plus 3x. And that is equal to 25. So look at each piece of the numerator and clean it up. And then I'm going to go ahead and I'm going to set it equal to 0. Now I have a negative x squared, so I think I'm going to choose to swing everything over there. That's your call. I'm going to move the x squared over. I have a 5x and 3x, so that's 8, and I'm going to subtract it over. I have a positive 10, so I'm going to subtract it and get a positive 15. Okay, so I'm going to go ahead and set that equal to 0, and then I'm going to factor it. So x minus 5, x minus 3, and that gives me x values of 5 or 3. All right, so now that I have that, I need to double check my domain restrictions. Clean that up. Domain restrictions, what can't x be? X cannot be 3. 5 is the constant, x can't be 3. That does throw that answer out. And so my final answer, even though it's there, I like to rewrite it very clear. So even though I have it here and I clearly threw that out, I like to sort of just show that final answer. Okay, so remember, this is not an easy thing to do if you have not built the skills to get here. And the skills to get here are solving equations, solving quadratics by factoring, using zero product property to solve, but also using zero product property for domain restrictions that can give us extraneous solutions. That's why I've been focusing on domain restrictions. The other things that are hard are following your rules for fractions abstractly. Following your, we weren't multiplying or dividing here. So no cross canceling. We could cross multiply, but we avoided it because it was going to make it more of a mess. It's going to give us higher powers and more things to deal with. So there were two methods, and one method, method 1, was to multiply everything there by the common denominator and see what cancels and what we have to multiply out. Method 2 is a method I prefer to show just because I think we visually sometimes need to see each piece and how it's built. But in method 2, we also rely on the idea that my denominators are going to cancel out. Okay, well, keep practicing this, and we'll see you for the next lesson.